So lesson 6.2 or the of module 6 is adding linear expressions. A learning target, I can use different methods to add linear expressions. Vocabulary in this case is linear expressions. So when we are listening to linear expressions, I put some expressions up here to figure out if these are linear or not. So the first thing is to understand what linear expressions are, okay? So, a linear expression is an algebraic expression in which each term is a constant or the product of a constant and the variable raised to the first power. So, it's got to be raised only to the first power, okay? When simplified, a linear expression cannot contain a variable in the denominator of a fraction. So cannot contain a variable in the denominator of an expression. Okay. So let's look at these, and we are going to take these and we are going to organize it whether it is linear or it is not linear. Okay, so I'm just going to put some more over here. Let's say I give you 5x and I give you um, 3x plus 2. All right, I give you x to the fourth power minus 7. Okay, so these are some of the terms I have, expressions that I have given you, and we are going to sort it out into whether it's linear or non-linear. Okay, remember this one, power of 1. Okay, this will be not a power of 1. Over here we will have a denominator which is a variable. This cannot have a denominator with a variable. So let's look at all of these. So if I look at 5x, okay, I can easily see that it is a product of a constant and the variable raised to the first power. So if I look at 5x, I have a coefficient and I have a variable, which is, if I'm saying x, it basically means it is raised to the first power. Okay, let's look at the next one, 3x plus 2. So I have a constant, I have the first power, so this is going to be a linear expression. Okay, that's a linear expression. Let's look at x to the fourth power minus 7. Is this raised to the first power? No, because it is raised to the fourth power. So therefore, this is not a linear expression. This is going to go here. X to the fourth power minus 7. Okay, let's look at negative 5x squared. Is the x squared raised to the first power? No, it is not the first power. It's the second power. That's why it's squared. So this is not a linear expression. We are going to write it over here, negative 5x squared. Okay, let's look at negative 4x plus 3. So yeah, here's a constant and x is raised to the first power. So this is definitely a linear expression. And I will write it as negative 4x plus 3. Okay, if I look at 1/2 x minus 5, so 1/2 is my coefficient, x is raised to the first power minus 5, which is the constant. So this is a linear expression. This is 1/2 x minus 5. So that is a linear expression. Look at the next one, 6 over x. In a linear expression, my denominator cannot be a variable. So because I have a variable which is x as the denominator, therefore this is a non-linear expression. And then let's look at the last one, x cubed plus 2. X cubed makes it a power which is greater than 1. And so we know that in the linear, my exponent can only be raised to the first power. So for it to be saying cubed, that means this is a non-linear expression. So this is the big difference between linear and non-linear. So if you can just look at these examples to get a better understanding. Okay, so now if you've looked at this, because we know what we can add and not add based on linear or non-linear. So we are now adding linear expressions, and I'm going to show you two different methods of adding these expressions. Okay. So if I give you a problem 4x minus 2, 4x minus 2, and plus negative 7x minus 3. Okay, so what I'm going to do, I'm going to show you two different methods. One is using algebra tiles. Okay, so I'm going to model each expression using these tiles first. Okay, so let's look at 4x minus 2. Okay, so let me take this part. So 4x minus 2. I am going to model this as, all right, I have 1x, 2x, 3x, 4x. I'm using algebra tiles to show you. Okay, algebra tiles to show you how to do this. Okay, so I have 4 x's, and from there I am removing 2. Okay, so I have minus 1 and minus 1 because I am removing 2 from there. Okay, then let's look at the next one. This is negative 7x minus 3. Okay, so this is negative 7x minus 3. So I am basically just first showing you these in algebra tiles. Okay, so how many negative x's do I have? 7. So I have 1 negative x, right? Because on the top we had 4x, but this is negative 7x. So I'm going to put negative x, 1, 2, 3, 4, 5, 6. I have 7 negative x's, and I have minus 3. So minus 1, minus 2, minus 3. Okay, so after this, I am going to look at where are my 0 pairs. A 0 pair is created by 1 positive and 1 negative. Just like saying 1 minus 1 gives me 0. So that is why I'm going to create 0 pairs now. Okay, so I have 1x minus x. Here's my first 0 pair. So I'm creating 0 pairs. Okay, and here's another 0 pair and another 0 pair, and I have another 0 pair. X minus x, x minus x. So I am creating 0 pairs. So then I'm looking at what do I have left. So I have 3 negative x's left, and I have, let's see, how many negative ones do I have over here? 1, 2, 3, 4, 5. So therefore, my answer for this is going to be, what do I have left? I have negative 3x, and I have minus 1, 2, 3, 4, 5, minus 5. Okay, so this is my final answer using algebra tiles. All right, now there is another method where I am going to arrange them in columns. Okay, so this was using algebra tiles, and now I'm going to show you by arranging in columns and solving it. Okay, so we have 4x minus 2 plus negative 7x minus 3. So we are going to rewrite subtraction as addition. Okay, so this becomes what? This becomes 4x. So keep, change, flip, right? So I am going to change the minus to the plus, and I am going to change the 2 to a minus 2. Okay, and I am now going to take the other one. I'm putting them as columns. So I have negative 7x. So I have negative 7x, right? So keep, change, flip, change the minus to a plus, okay? And change the 3 to a negative 3, okay? So what I'm doing now, I'm just going to show you. So I'm taking these two and I am adding, because I am adding my linear expressions. And so now it's very, because I have the same variables or the same terms or the same constant. So then I can add or subtract. Now, if I look at this one, what do I have? I have opposite signs. So based on the rules we've learned, we are going to take the absolute values of both and subtract and then give the sign of the bigger number. So what is 7 minus 4? I'm going to get 3x, and the sign in front of this 7, which is the bigger number here, is negative. So this is going to be negative 3x. All right. And then I have plus, since both negative 2 and negative 3 are the same sign, we are going to add them, and that becomes negative plus negative 5. So once I rewrite this, this is the same thing as saying what? Negative 3x minus 5. So look, whether I do it this way in columns method or I use algebra tiles, so this answer is going to be exactly the same. So both the methods are perfectly correct. All right. So let's try another one really quick. And I give you my problem as 5x minus 4. I'm just going to put it in the column method. And you are free to use either method. So I have 5x minus 4. Okay. And I have plus negative 2x plus negative 2x plus 2. Plus 2. Okay. So I'm going to put them in the column method. I'm going to write 5x. So keep, change, flip, change the minus to a plus, change the 4 to a negative 4. Okay. And over there I have, so I'm going to add, I have negative 2x plus 2. All right, I have negative 2x plus 2. So if I look at this, again, opposite signs, what is 5 minus 2? I get 3x. Sign in front of the 5 is positive, so we are going to have a positive 3x. And then I have plus. Now I can see opposite signs, so I'm going to subtract, and I get negative 2 because the sign in front of the bigger number is negative. Okay, and this can be written as 3x minus 2. Okay, 3x minus 2. And now they are unlike terms and I cannot add or subtract. But this is how we solve adding linear expressions. Let's try one with fractions now. Okay. Okay, so we're going to try one with fractions. If I say 1/3 x plus 9, 1/3 x plus 9 plus 5/12 x, 5/12 x minus 4. So here are my terms. Okay, so we're going to write the original expression. We are going to rewrite subtraction as addition. Okay, so in the first one, it's addition. So 1/3 x plus 9 plus, we are going to rewrite, keep, change, flip, keep 5/12 x, change the minus to a plus, change the 4 to a negative 4. Okay, so here is my rewritten expression. All right, now next I am going to arrange like terms in columns. So I am going to have 1/3 x plus 9, and I'm adding the linear expressions. I'm going to do 5/12 x plus -4. Okay, now if I'm looking at this, it's basically always focus on the numbers in the front. Don't focus so much on the variable. Of course, you've got to add the variable at the end. But if I'm looking at the fractions, I can see that they do not have common denominators. So the next step is to find a common denominator. And by looking at 3 and 12, I know that my common denominator is going to be 12. Okay, so I'm just going to do this so I can show you what I'm doing. All right. So 1/3, that means how do I get 12? I've got to have the same common denominator, and this is plus 9. And then of course this is already 5/12x plus -4. Okay, so plus -4. And so now I'm going to change this to common. So 3 times 4 gives me 12. Okay, this is basically what I've done. And then 1 times 4 is going to give me 4. So now I have common denominators that I can add over here. And now I'm going to add these. Okay, and so if I have 5 plus 4, I get 9/12x. And since I have opposite signs, I'm going to do 9 minus 4, and the sign in front of 9 is positive, so this is what I'm going to get. And then I am going to simplify the fraction because 9 and 12 are both divisible by 3. So 9 divided by 3, because I've got to put the fractions in the simplest form. So I'm dividing by 3. And 9 divided by 3 is 3. 12 divided by 3 is 4. 3/4 x plus 5. Now I can see that these are unlike terms, and so 3/4 x plus 5 is my final answer. All right, so same thing. This is like just adding linear expressions. You are welcome to use algebra tiles or the column method. Column method becomes very simple. Make sure that you're doing the keep change flip if there is subtraction, or changing the minus to a plus, or adding the opposite. And then you align in columns the same variables and the same constants together, and then you can add them. And make sure if you have fractions, you've got to have common denominators, and please make sure that the final answer fractions are put in the simplest form. So this is how we add linear expressions. All right, have a great day.